Hello, I'm Lisa Stark, and this is Newsmakers from ABC News and Yahoo News. And we're here at the historic National Air and Space Museum in Washington, D.C., and we're going to talk to Dr. Ed Lu. He's a former astronaut. He launched twice on the space shuttle. He also spent 6 months on the International Space Station. But now he is focusing on asteroids and the potentially cataclysmic threat that they pose right here to planet Earth. So Valentine's Day is around the corner, and we're probably going to see some candy and flowers, but we're also going to see something unusual around Valentine's Day. What is that?
There's a pretty cool sight in the skies the day after, February 15th. And what is going to happen is we are going to be barely missed by an asteroid.
A whisk. It's going to whisk right by us.
It's going to miss us by just 17,000 miles. And
is that barely?
That's barely. If you think about the fact the Earth is a moving target.
Okay.
So we're moving at about, right now at this very second, 65,000 miles an hour around the sun.
Whew.
So the Earth covers 17,000 miles in about 14 minutes.
Oh, wow.
So it's a really close shave because this asteroid is big enough, if it hit, to take out an area roughly the size of metropolitan DC.
Now, isn't this what did the dinosaurs in, or one of the things that helped
do the dinosaurs? A very much larger cousin is what actually knocked out the dinosaurs. You can think of it as playing sort of roulette with the Earth. Every few hundred years, something like this happens on Earth.
And how do we know this asteroid is coming toward us? How do we even know this asteroid?
This asteroid was spotted a year ago.
Okay.
When it also came near the Earth, because its orbit crosses Earth, so it kind of regularly comes by. And it was spotted by chance, as most asteroids are. I mean, we have observatories looking for them, but they scan the sky, and they see the ones that come close to the Earth. They come very close to the Earth, and they see them when they're on the dark side of the Earth, because you can't look towards the sun. And you see them when the moon isn't full, when it doesn't make the sky bright and you can't see asteroids. For every one of these out there that we see, there's 99 more out there that we haven't tracked yet. And we don't know where they are. And we think that's kind of crazy. So we decided that we're going to go out there and find them. So we have been raising money, actually, quite successfully. And we are launching in 2018 a space telescope, but it's not going to orbit the Earth. So our telescope is going to go inwards and it's going to orbit the sun in an orbit very similar to the way Venus orbits the sun. So we're actually going to use the gravity of Venus to pull it into orbit around the sun. It actually will scan Earth's orbit as it goes around.
And so what is the hope? What are you going to use this telescope for ultimately?
We're going to map for the first time the locations and trajectories of the inner solar system. If you think about it, it's like a three-dimensional dynamic map, right? Because all these asteroids are moving, as is the Earth, right? And right now, if you look at the map, there's sort of the great unknown out here, because we can't point our telescopes towards the sun.
Right.
And so, we know where Mercury is, we know where Venus is, we know about 1% of these asteroids. The rest, big question mark. So if you think about it, what it really looks like, it looks like a swarm of asteroids moving around the sun, and the Earth is moving all through that. And we're going to fill all that in. And that'll allow us to know if any of these is going to hit the Earth.
And how far in advance might we know that once you track all these? Decades.
Yeah. And that means that deflecting them is actually pretty easy.
How do you deflect an asteroid?
Well,
it sounds like something out of Hollywood or something.
Yeah, science fiction is sometimes, science reality is sometimes kind of cooler than science fiction.
Okay.
All you need to do is 50 years from now, make that thing be early or late to the collision point by a few minutes.
And how do you do that?
You simply run a small spacecraft into it. It's really easy.
You run a spacecraft into it?
Yeah, we've done this before. We did a mission called Deep Impact, not the movie.
I was going to say, wasn't that a Hollywood movie?
Yes, it was, unfortunately. They ran a spacecraft into a comet, and it actually changes the velocity of the comet slightly. That's enough. What people fundamentally don't understand is that deflection of asteroids is easy compared to finding them. So the hard part is what we've decided to take on, which is finding and mapping them and knowing which ones are going to hit us, because you have to track 1 million objects, okay? And we're going to do that, and then we will deflect anything that hits us. I'm confident.